Okay, YouTube, in this video we're going to continue our exploration of factoring algebraic expressions, most specifically though quadratic expressions of the form ax squared plus bx plus c, where a is specifically equal to 1. So you can see that each of my expressions over here that we're going to be factoring are all quadratic and they all have a values of 1. What we're essentially doing is undoing what we call the FOIL method of multiplication. We want to rip it back apart into its two binomial parts, and binomial just means that it is an expression with two terms in it. Whereas over here, these would be trinomials. So we say, consider multiplying a pair of binomials. When doing so, we use the FOIL method. So remember, FOIL just stands for first, outside, inside, and last in terms of the order in which we multiply these terms. And so we'll just run through this. We get x times x is just going to give us x squared here. So when you multiply the first two, we get this leading x squared. And then we would say outside, we get negative 3x. Here we would do the inside and get positive 5x. And then we would say, checking the last two terms here, we would get a negative 15. And it is appropriate to go ahead and combine these like terms here. So we would say overall we get x squared plus a positive 2x minus 15. And so what I want to do is really just relate this positive 5 here in this binomial and this negative 3 to the expression that we got in the end. And so the things I want to point out are these. Essentially, what was inside the front of these two binomials here, those first two always guarantees that we get that first term right there. And then when you look at the last in the FOIL method here, these last two, which are the 5 and the negative 3, those are always going to multiply out to be your constant term here. Okay. So what I notice instantly is this. We'd say that whatever goes in here, this positive 5 and this negative 3, they multiply out to be this last number right here. And the other fun thing about this is they actually add up negative 3 and positive 5 to be this middle number. So using this to our advantage, we say we can observe that in the result that we obtain, we have a trinomial of the form 1x squared plus bx plus c. We say the two factors in the binomial above contain values that multiply out to be the value of c. So they multiply out to be this term, multiply out to be this, multiply to be c. And then we would say the two factors in the binomials above contain values that add up to be the value of b. So we would say that these two terms here, positive 5 and negative 3, they sum up to b. So that being said, what I want to do is kind of try to work backwards and say, well, looking at this expression right here, could I have thought of two numbers that multiply out to be a negative 15 that actually add up to be a positive 2? And if we can, we could rewrite this as the product of two binomials, which would be in a factored form, because recall, when you factor something, you're just tearing it down into a bunch of things that multiply out to be it. So what I want to do over here is factor these three expressions, starting with this first one here. So now, if it's factorable, then it will factor these trinomials down into a binomial, a pair of binomials multiplied by each other. So the first thing I want to mention here is this x squared right here. Remember in the FOIL method, F-O-I-L, these two terms that go on the front are the ones that guarantee that we get this first term. So the only thing I can think of that I would multiply together would be x and x to get this x squared. So now the next thing is this. We said, well, these two terms right here that go right there and right there, they have to be numbers that multiply out to be this 2, the ones in the last spots. So if I said what numbers multiply out to be a 2, I could think of 1 and 2 or negative 1 and negative 2. But out of all of these possibilities here, which there are only a 2, we say which ones also add up to be a positive 3. And I notice that positive 1 and positive 2 would do this. So positive 1 and positive 2, this would certainly be easy to check. We get x times x is x squared, and then the 1 times 2 give us the 2 in the back. The question is, do we get this 3 here in the middle? So checking our outer and our inner here, we would say we get 2x and 1x gives us this middle 3x. So this is the factored expression of the original trinomial expression. So looking at this next one, let's try to do this a little bit more quickly. We say two numbers that multiply out to be a negative 80. So there are many possibilities here. We have negative 1 and a positive 80, positive 1 and a negative 80. We could say a negative 2 and a positive 40. We could say a positive 2 and a negative 40. Let's see. We could say 4 times 20. So we'd say negative 4 times a positive 20, a positive 4 times a negative 20. And, you know, we could get even more exotic here. We say negative 8, a positive 10, and we say 8 and negative 10. The idea is we could list all of these, but essentially, really, we could just kind of think about this one out loud. We need two things that multiply out to be a negative. So one of these has to be positive, the other one has to be negative. And when we add them up, we get positive 2. So essentially, I need two factors that are really 2 apart from one another, and the positive one must have been the bigger of the two. So I would say, well, what factors are 2 apart from one another? It'd be these sets down here, and we would say, well, a negative 8 and a positive 10. When I add those up, I get a positive 2, and when I multiply them out, I get a negative 80. So it must be that we get a negative 8 and a positive 10, and you can always check your work. So this last one here, even quicker. We say, okay, without listing out all the factors of negative 35, we're questioning ourselves. We say, can we think of 2 that multiply out to be a negative? So we automatically know that one has to be positive and the other one has to be negative. And we say they also have to add up to be a negative 3. So if I said, well, how about 7 and 5? 7 and 5 there, okay, well, you could say, how about a negative 7 and a positive 5? But they would add up to be a negative 2, so that wouldn't work. So what other numbers multiply out to be a negative 35? We say 1 and 35, but if I do those, I say maybe a negative 1 and a positive 35. Those add up to be 34. And we could even switch the signs around and be negative 34, and even switch the signs around on these and it'd be a positive 2. The idea is that I can't think of any. So if that doesn't work, then we say that this expression is prime and cannot be factored. Cheers.